Specimen paper 2. Here are the sample or model answers. Program variables have values as follows. All the values are given. Then give an appropriate data type for each variable. So today is this, it's a string, Tuesday. So we have to put string here. Week number, it's an integer. Revision, just one character and single quote marks generally indicates that it's a chart. Max weight, decimal point, so it's real. Last batch, true, which indicates that it's a Boolean variable. Evaluate each expression in the following table. If an expression is invalid, then write error. Refer to the insert for the list of pseudocode functions and operators. We can make use of the insert for the functions. So the very first one is mid today 3, 2, which means today. Take today is a Tuesday. Of that, start at 3 and 2 characters. That's meaning. So start at 2 means 0, 1, 2. 0, 1, 2, that is E. And 2 characters means ENS. ENS. Then and means concatenate. Connect them together. Revision, that is one thing. Before you connect ape. Revision is C. Revision is the character C and it's capital C. See, it's capital C. So you have to put ES from the first one, from this, and capital E from here, and just a string constant here. Nothing to evaluate. APE. These two we evaluated. This is just a string literal or constant. Escape. The same spelling like capital C there in the bit. Then integer of max weight plus 42. So max weight is 60.5 plus 42 means 64 plus 64.7. So 64.7, it's not rounded up when you say int, it just takes a whole number part only. So it's 64. Length of max weight. Max weight is a number. There is no length for that. Length is only for strings. So it's error. And mod week number 12. That is week number is 37 divided by 12 and the remainder. So 12 times 3 is 36. The remainder is 1. Revision less or equal to D. Correct? Yes, that is true. Revision is C means less or equal to D and not last batch. Last batch is true. So this is false, no? This is last batch. But this is not last batch. Then it's false. So true and false will be false. This AND operator here, logical operator. Simple algorithms usually consist of input, process, and output. Complete the table to show if each statement is an example of input, process, or output. Place one or more ticks for each statement. So, some chars, some characters equals hello world. That's a process. Like assigning this value into this variable. It's a process. Output, so that word itself says output, so it's an output. But there is some processing also going on. But not the whole thing. From these some characters, only the right side 5 characters. From the right 5 characters. So there is both output as well as processing. Then the next one is read file. So input, my file, my character. So there is processing also. From the file, you have to take it one line or some characters. That's also a process. Write file, so out. Write file is output. My file and data is, all those things are processing. Concatenation and all that processing. Write in pseudocode a post condition loop to output all the odd numbers between 100 and 200. So there are two methods. I have given both methods. Method 1 is start with C equals 100. Initialize Z with a value of 100. Then repeat until C equals 200. So which means between 100 and 200. If C mod 2, C is this, first time it's 100, mod 2 equals 0, no? So it's not an odd number. If it is, so nothing happens, only C equals C plus 1. Then this becomes 101. C becomes 101. 101 mod 2 is 1. So it's an odd number. So output C. So you start outputting with 101 until 199 it will go on. Method 2 is C equals 101. You initialize with 101. Then repeat. Straight away you start outputting C, but add 2. C equals C plus 2. So that means the next one is 103. Then 105. Likewise, it will go on until 199. Question 2. Roberta downloads music from an online music store. The diagram shows part of a structure chart for the online music store program. So the main task is checkout, then card payment, and A and B parameters are passed to the card payment, and then from there, Boolean. This is black, it's Boolean. Boolean flag is returned, then account payment. The payment is done. Say 3 items of information that the diagram shows about the design of the program. 1. This diagram has identified the 3 modules, that is checkout, card payment, and account. So it's modularized. They are in 3 modules. 2. The hierarchy of the modules is shown. So it's given in levels. It also shows the transfer of data between modules through parameters. So these A, B, and C are parameters. Examples of the data items that correspond to the arrows are given in the table. A is an amount, B is a name, C is true. Use pseudocode to write the function header for the card payment module. So it returns a value. We saw it in the diagram. This is returning a value, which means it's a function. Anyway, this has mentioned function also. You can't go wrong. Function header. To start with function, the word function. Card payment is a name given there. And amount is real. The parameters that are passed, amount is real. Name is string. And returns Boolean. So that's for C. Returns Boolean. That's a header. So actually, that's not a big question. It's small, A and B, very small. But 6 marks. Remember this function header, it's only that, just one line. Function header or procedure header, just one line. But we have to give all the parameters and their types. Question 3, a stack is created using a high-level language. The following diagram represents the current state of the stack. The top of stack pointer points to the last item added to the stack. So E is the last one and the top of stack is pointing towards E. Starting from this side 99, going down. Right? Two operations associated with the stack are push and pop. Describe these operations with reference to the diagram. My var equals pop function. Whatever. Variable my var, variable called my var, will be assigned the value E. That is because when you push, the last one will come out, which will be removed from the stack. Top of stack will increase to 102. So top of stack increase to 102. So this will come down because it is increasing downwards. Top of stack will go downward. Then push Z. Push Z. Z will be stored in address 101. Because now E is removed and Z will come here, and also top of stack will decrease to 101. Decrease being going out. So top of stack will go to 101. Two programs use a stack to exchange data. Program add string pushes a string of characters onto the stack, one character at a time. Program remove string pops the same number of characters off the stack. The character at a time, one character at a time. The string taken off the stack is different from the string put on the stack. Explain why the strings are different. Do you know that in the stack it's LIFO? Last in, first out. So stacks work according to LIFO method. The last character of the string will be the first character of the new string when popped by remove string. So that will be the reverse of the original string. Then question 4. Parameter X is used to pass data to procedure myproc in the following pseudocode. X equals 4, call myproc X, passing the parameter X is passed from here. Then output X. What happens in the procedure? Procedure myproc X is received here and declared as an integer. Declare Z also as integer. That's a local variable. X equals X plus 1. Z equals X plus 3. And procedure. And what happens here? Output X. When it encounters this call myproc, it will come here. When it finishes the procedure, then it will come here and output X. There are two parameter passing methods that could be used. Complete the following table for each of the two methods. Name of parameter passing method by reference. If it is by reference, value is 5. The address of the variable is passed because the address is passed, that is X. So the variable gets changed when parameter values change within the module. So here when it changes, X equals X plus 1, X becomes 5. So the answer is 5. Whereas by value, it's 4 because a copy of the value is passed without any reference to the original variable. So only a copy of the value is passed, only 4. So it will be used. It will be used here, but that's a local one. Only changes there. It doesn't alter the original X. Original X remains 4. That's why it's 4 here. Copy of the value is passed without any reference to the original variable. So the original variable value remains the same, even when values change within the module. The pseudocode includes the use of parameters. State 2 other features in the pseudocode that supports a modular approach to programming. It shows procedures and local variables which support modular programming. One is it shows procedures. Local variables which support modular programming. What is that? is a modular is a calling other modules. And then local variables are here. Local are here. Inside the procedure is local. It's not valid here. The company keeps details of its produced items in a 1D array or stock. The array consists of 1,000 elements of type stock item. The record fields of stock item are field, product code, typical value is this, price and this value, and number in stock, this value. You are required to write pseudocode to declare the record structure stock item. So type, just like declaring the procedures and function. The record structure, it's a type. So you start with type and with end type. This is a name, stock item. It's given, you have to use this name. And the three fields are declared. Declare product code as string. Declare price as real, where there's a decimal point. Declare number in stock integer. End type. Write pseudocode to declare the stock array. Declare stock is the name identifier as the colon array and the elements 1 to 1,000 of what is the type? Stock item of this type. Right? Write pseudocode to modify the values to element 20 as follows. Set the price to 105.99, increase the number in stock by 12. So how do you access this 20th record? Stock is array name, the element is 20, dot, where is the record type, the dot notation comes in, dot price. That's how you access this price. You change it to 105.99 and same way stock 20 dot number in stock. That's a field. It becomes stock. You're adding, no? Increase the number in stock by 12. So what is already there? Stock 20 dot number stock plus 12. You add 12 to what is existing there. The stock report program is developed. Write pseudocode to output the information for each stock item that has a price of at least 100. Output the information as follows. Product code, like this is a sample, this is a product code, number in stock. Declare n as integer. Or then you have to start a loop to run 1,000 times, or n equals 1 to 1,000. If stock n, so that's you are using this n value, dot price is greater or equal to 100, because this says item that are a price of at least 100. At least 100 means 100 also has to be included, and anything greater. So greater or equal to 100, then output product code. This is this part, this product code here. Then colon is also there within inverted comma, and this is a concatenation and stock n dot product code. That's product code this part, and number in stock, that is this part, and that is another field, stock n dot number in stock. So that is this part, 15. End if. Then next. Members, question 6. Members of a family use the same laptop computer. Each family member has their own password. To be valid, A password must comply with the following rule. It has to be at least 2 lowercase alphabetic characters and should have at least 2 uppercase alphabetic characters, at least 3 numeric characters, alphanumeric characters only, and it should be alphanumeric characters only. A function called validate password is needed to check that a given password follows these rules. This function takes a string called pass as a parameter and returns a Boolean value. True if it is a valid password, false if it is not. Write pseudocode to implement the function validate password. Refer to the insert for the list of pseudocode functions and operations. Function name is validate password and the parameters pass the string. I mean the pass as a string. Password which is entered, pass as string, and returns Boolean if it is true or false if it is not. Declare lowercase char, lowercase character, uppercase character, num character, number of characters, n as integer, all these as integer. And then declare next character as char. Declare return flag as Boolean. And also you initialize the return flag as true, lowercase L case character 0, uppercase character 0, num character 0, okay, and equals 1. So all the variables that are declared here are initialized also here. Then you start the loop. This is a condition. While n is less or equal to length of pass. So the length of this password, this character here, this one. Up to that point, you have to do from 1, because n is 1 here. And one condition that will start from the first character to the last character to be checked. And also return flag equals true. Now at the moment, return flag equals true. So it will start working. And the length is also valid. The return flag is also correct. True. It will start. Next char equals mid of pass n1. That is, pass is the password entered. Of that, mid means you can start at any point. Starting at the first point now, because n is 1, comma 1 character. So that first character is taken into next char. Then if next char greater or equal to simple A and next char is less or equal to simple Z, then L case char equals L case char plus 1. So you're counting the number of lowercase characters. Else, if it is not a simple letter, if next char equals greater or equal to A and now if it is A to Z, then uppercase character U case char equals U case char plus 1. So you are adding 1 to the capital letter. Even that is not true, I mean not lowercase, not uppercase, then if next char equals greater or equal to 0 and next char equals less or equal to 9, means 0 to 9. Then num character, num char equals num char plus 1. You add 1 to the number of number characters. Counting the numbers. Else, return flag equals false. That is illegal character. If you have entered an illegal character, false. Return flag is false. End if, that is for this. This end if is for this. This end if is for this end if. And n equals n plus 1. And n while means you go there and starting with n equals 2 the second time. But supposing, then you go on like this. You go on until one of these things is wrong. That means if the password character is 8, password length is 8, and if n becomes 9 at this point, that means it's not found yet, no? Becomes 9, then also this will stop, or else if there's a wrong character, none of the valid characters are there. If it's an invalid character comes, then return flag becomes false. In this case, also it will stop. If this is full, also it will stop with the return flag true. But if it is not full or full, but it's not valid, even one character, at least one character. If it's the first one, for example, if you enter question mark is not valid for the first character, then n is 1. So at the very first time, question mark is taken. It's not here, it's not there, it's not here also. And then what happens? Return flag equals false. So n equals n plus 1, it's 2. Go back here, n is 2, but this is false. And since this is the AND condition, if any one becomes false, then the whole thing is false, and then this exits. It doesn't continue, comes down. So in whichever case, when it comes down, it will carry the flag. If LK's char is greater than 1, that means because the requirement is at least 2 lowercase characters. That means there can be 3 or 4 or 5, any number of lowercase characters, but at least there has to be 2 lowercase. So there upper also 2, and numeric has to be 3 at least. And also alphanumeric means either alphabetic or numeric only. These question marks and all that not allowed. So if this is greater than 1 and uppercase also greater than 1 and num character greater than 2. Why? Because minimum it has to be 3. Minimum it has to be 3. These two, minimum 2. And return flag. And return flag means return flag true. You can, if you want, you can say return flag equals true, but just normal return flag means it's true. Then return flag equals true. Else, if none of these, if any one of these is wrong, either lowercase character is only 1 or none, uppercase character is 1 or none, numbers either 2 or none, 2 or 1 or none, and return flag is false, then it will be false. But if this is a complying, this is correct, this is correct, this is correct, and this is correct, then return flag equals true. Else return flag equals false. And then return, this is a function, return flag, return the return flag, whether it's true or false, and it's the end of the function. Let's have a look again. Right, so to go to implement the function valid password, refer to the true if it is a valid password, false otherwise. So that will return whether the password is valid or not. The validate password function will be tested. Give a valid password that can be used to check that the function returns true under the correct condition. So here I've given 2 capital letters, 2 simple letters, and 3 numbers. So it's valid. Password 1 is modified to test each rule separately. Give 4 modified passwords and justify your choice. You have to test each rule. So password to test rule 1, PAB321 is the um, first rule is the lowercase, uppercase, sorry. Okay. To test uppercase characters, this one, right? Because only one capital P is given. Otherwise, the simple letter is correct, the number is correct, but only one capital P, so it should be wrong. Then test rule 2. I have given P, Q, QB to test lowercase characters. This time the capital is correct, but lowercase is wrong. Only one lowercase. And the next one is only 2 numbers. All the other 2 are okay. P, Q, A, B, and 3, 2 is wrong. Only 2. To test numeric characters, P, Q, A, B, I have put a asterisk, and after 3, 2, 1. Asterisk. So that is also wrong. To test invalid characters. When using the validate password function, a module, it is necessary to test all possible paths through the code. When testing the valid password function, a module. When testing the validate password function, a module is necessary as a module, I think. When testing the validate password as function as a module, it is necessary to test all possible paths through the code. State the name given to this type of validation testing. This kind of validation is called white box testing. That is because it's transparent, like you can see. Because a program only can do this, not the layman or the user, where they don't know the program. So here, possible paths means like if, then, else, and various things. One path is if, then the other one is else. 2 paths there. So like that, you can go along 2 different paths of a program. So this is called white box testing. A program consisting of several functions can be tested using a process known as stub testing. Explain this process. It is useful to carry out testing even before the modules are completed. Module stubs can provide a known response to confirm that a call to the module will really work. Okay? Before the whole program is done, you take stubs like small program, just enter a module and exit just to see whether it works. So module stubs can provide a known response to confirm that a call to the module will really work. That is also something like that, like a menu item, whether it will work. If you take option 1, whether it will go there. That kind of step by step you can check. That is stub testing. Question 7. Log array is a 1D array containing 500 elements of type string. A procedure, log events, is required to add data from the array to the end of the existing text file, login file.txt. Login file.txt. Unused array elements are assigned the value empty. These can occur anywhere in the array and should not be added to the file. Write pseudocode for the procedure log events. Refer to the insert for the list of pseudocode functions and operators. So log events, what does it do? Procedure log events is required to add data from the array to the end. So there's an array called log array, 1D array of 500 elements, all the strings. data from the array to the end of the existing text file. Login file.text and unused array elements assign the value empty. So procedure log events, that's the name of the procedure. Declare file data as string, declare array index as integer, open file, login file text, that's a name of the file. Open file, login file.txt for append, because you use write, it will erase every line. Every time you run this, it will erase. So we have to append to the end of the file, one below the other, one after the other. Then the loop begins for array index. That array index we used here as integer, that's a number. Array index is equals 1 to 500. So array index 1 to 500. If log array, that's an array, and the array index is the number here beginning with 1. If the first element not equal to empty, then file data equals log array index. So the very first element is taken to the string called file data. What we declared here, file data. Then you write file, the file name login file.txt, and file data is the string that is to be written. And if then next we'll go to the next array, the second element, and goes on. Only if it is not empty, it will be written. If there are empty elements which are marked empty, they will be ignored. They will not be written to the file because of this condition here. If log array index not equal to empty, only this will happen. So 8 marks for that. That's the end. It's the end of it. And altogether you have 75 marks for this paper.